One of the things that they asked us to make sure that we talked about in a trig class actually has nothing to do with trig, really, but they wanted to have one more reinforcement of logarithms because they are important as you go into calculus and other classes. There's logarithmic differentiation, and we actually use the properties of logs to really help simplify things. And so, as you see here, we're making sure that you remember what the logarithm is. So what you're seeing right now is the graph of 2 to the x. And we want to use that to show the graph of log base 2 to the x. And so this should not be the first time you're learning about logs. So let me remind you that log base 2 of x is looking for the exponent that you need to put on 2 in order to get x. And so let's look at something really quick. Let me get a good color pen here. So if I were to ask you to do what they want us to graph is this guy right here, f of x is equal to log base 2 of x. So if I ask you for something like f of 0, which is log base 2 of 0, hopefully you'll realize that that is impossible. So the red graph is the line, is the graph of y equals 2 to the x, and it never actually reaches 0. So this is undefined. Okay, and so we can't do a 0, but what if we did log base 2? And what if we did f of 1? So log base 2 of 1. We'd be asking ourselves, what do we have to raise 2 to in order to get 1? And so as we plug in 1, we're going to get out 1. And so, we're going to get out 0. So we're going to cross right here. Right? Because the power that we have to raise 2 to in order to get 1 is 0. So let me translate this out. Remember, this is 2 to the 0 is equal to 1. That's a true statement. To the 0 power is 1. So it's going to look like that. It's not going to ever get to the 0 part. So that's an asymptote. It's going to look like that. And then it's going to look just like this as time goes on. Right? Because if we did something like f of 4, we'd be looking at log base 2 of 4. Well, we know what that is. That's 2. So as I go out to 4, I should be up to a height of just 2. So I'm not bending as much as I should. But there's the graph of the general log function. So the domain of the log function is actually the range of the exponential. So the domain is from 0 to infinity. And the range is from minus infinity to infinity. Okay, you'll be able to get out any power that you want. You can raise something to any power. So what's the asymptote of this graph? The asymptote is the line y equals 0. Right? It gets closer and closer to that, but never actually touches. What is the base in y equals log of x? So we want to remind you, if there's no base written, that base is understood to be our number base system, 10. What is it called? It's called the log, I guess. What is the base in y equals ln x? Well, ln x, maybe you remember, hopefully you do, that the base there is e. We use ln a lot because e, the natural number, is used a lot as we do things that are happening in nature. What is it called? It's called the natural logarithm. So if you ever heard of the natural logarithm, or if you ever hear of that, it is ln. So as we come up here, we know what these are going to do. They're just reminding us that if you apply a negative to that, then it's going to take things that were negative and make them positive in the y value. And so we're just going to take this blue graph off to the side and flip it. Log base 2 of x plus 3, you know what that's going to do. That's going to move this back 3 units. So instead of going through 1, 0, we're going to move that back 1, 2, 3 units, and we're going to look like this. And it will have an asymptote here, just 1 behind that, so an asymptote at negative 3, right? Yeah, negative 3 coming through there. I did that again. Okay, let's see if I can get back to where I was pretty quickly. Okay, maybe not so quickly. Sorry about this, but it's probably going to be the fastest way to get back up to those things. You can see what we're going to talk about next, some vector stuff. There's the log homework that you're going to have to do, and we were right here. Before I touch that, log of x plus 3 is going to take where we were and move us up 3 units. So I always use a crux point in there. Still have the same horizontal asymptote, but we're just moving up 3. And then if it's negative x, then everything switches on the other side of the y-axis, but it would look just like that. Right? We'd still have 0 as the asymptote because we can't plug 0 in. So I don't think you'll see any questions like that, but you will see some log interpretation questions. So what we want to remind you of is, the definition of logs. So if you have log of 0.1 is equal to -1, we need you to be immediately able to translate that to its exponential, which is the base 10 raised to the exponent, what the log's equal to, and is equal to what the log is operating on. I'll put the 0 in there. ln of x is equal to a. What's the base? E. What's the power? A. What's that equal to? X. Okay. Rewrite each into its logarithm form. Log base 10, well, we don't need to write the 10, of 137 is equal to the exponent. Right? We're just reminding you of a core algebra 2 skill. If you missed this in intermediate algebra, they messed you up a lot. We're just ideally reminding you. So log, what's the base? 32. What's the power? Oh, sorry. If I ask what's the power is 2/5. That goes over here. And what's the result? 4. So logs are important because sometimes we need to get to those exponents. And again, the properties of logs is really what helps us out. Solve each equation for x, where f of x is equal to log base 2 of x. So now they want us to find log base 2 of log base 2 of x is equal to -1. Well, the best way to solve that log equation is to put it in its exponential. The base to the power is equal to what log's operating on. So what's x? Simply 1/2, and we're done. F of x is equal to 3. Awesome. So that we need log base 2 of x is equal to 3. So I know that 2 to the third is equal to x, or that 8 is equal to x. And we come up with our answers just like that. So it should be quick. We just are under the task of reminding you what to do. Now we're going to plug stuff in. So f of 1/16 is log base 2 of 1/16. So we just have to ask ourselves, what power do we need to raise 2 to in order to get 1/16? Well, hopefully you remember to get a fraction from a number like 2, I'm going to have a negative power to flip it. And the fourth power gets me the 16. So 2 to the fourth is 16. The negative will flip it. If we look at log base 2 of 2 and ask what power do we need to raise 2 to in order to get 2, the obvious answer is 1. And so, again, really quick if we know logs. And now we're going to use the property of logs. They took some time to remind us what those are. They want us to rewrite this in terms of just bare bones breaking it down. Did it again. Okay, we're close here, so I'll come back up. Okay. All right. So here we are working with the properties of logs. So what we want you to realize is at first this is log of 10a minus log of b. That's its power. It could take a quotient and split it up. And then they want us to go even farther. This is log of 10 times log of, plus log of a minus log of b. So what am I using? I'm using the properties that are up here. The first one that I used was this guy right here. That you have a division, you can split it up as a subtraction. The second one is this one right here, if you have a log of a product. Now there's one more thing that we should do. We know what log of 10 is. Log base 10 of 10, what power do we need to raise 10 to in order to get 10 is 1. So now we have 1 plus log a minus log b. How about this one? If we take a look at this guy, this is, if we use the property that's not boxed up here, let me come back and erase some stuff. Get my thing up here again. Let's focus on this property right here. Okay, there also is an intuitive way to answer this. So whatever your intuition is. So this says I can bring down the 45 and look at log base 7 of 7. I can bring down that power. You know what this is. Log base 7 of 7. What power do we need to raise 7 to in order to get 7? 1. And so not surprisingly, the answer is 45. Now, let's make sure you understand that. The original problem was saying, what power do I need to raise 7 to in order to get 7 to the 45th power? Most of us would just answer 45. How about here? Do you remember what the fifth root of e as a power is? Hopefully you remember it's 1/5, a core part of intermediate algebra, never to be taught again, right? Only to be used. And so we use this context to remind you of that. Well, look what this is asking for. It's asking for the power to raise e to in order to get e to the 1/5 power. We get 1/5 out of that. We shouldn't be surprised as well because logs and exponents are inverse functions of one another, so they undo one another. And then this last one is very common. Right here, I'm going to use the property that if you have a division, you can split it up over a subtraction. Now there is a common error here. The next problem I'm going to do is bring down that 3. They'll want us always to get it into these logs of single things with no powers. So that's 3 log of x going along for the ride minus, and then be careful here. This is definitely log of y plus log of z, but the whole thing's being subtracted. So when you see it in the back of the book, it's going to look like this. Minus log y minus log z. Right? Everything on the bottom is negative, if you remember. Everything on the top is positive. You can get to these really, really easily. So this is sections worth of work in an intermediate algebra class that we're condensing down to this one, hey, remember this type of thing. You will see some log questions on the exam, but not an overabundance of them, but enough to make sure that we meet the curriculum outline of reminding you about these before you need to use them in your pre-calc and calc class pretty fluidly in those classes, but pre-calc will also remind you of them. So if you remember how to solve exponent equations, log equations, 99% of the time they're solved the best by just going through the definition of logs. So remember what this is. This is log base, well, there is no base written, so it's 10 of x minus 3 is equal to 1. Let's just translate that to its exponential. That's 10 to the minus 1 is equal to x minus 3. That's 1/10 is equal to x minus 3. So x is equal to 3 1/10. I'd be okay with that. The other thing you could do is 31/10. Okay. So, right, you okay with where I'm getting 31/10? Just change that to its improper fraction form. And then how about this one? X to the 1/3 power is equal to 2. We know how to get to x all by itself. We just raise each side to the 3rd power. And so we find out x is equal to 8, and we're finished. And so what's here for you in the homework assignment, because it's not found in our book, because they assume we already know about logs, and is a log homework exercise that you're going to go through. And I can post answers to it. But it's 2 pages long. And you're going to just go through and answer these log questions as part of the homework assignment. And I'll highlight that when in the announcements as well. But that's your brief review about logs, and you can test your knowledge as you go through this homework and example one and get your own practice with that. But let me know what questions arise, and I'm happy to work them out. But I will also provide answers for those and post them on Canvas.